We're now going to do multiple regression with this data set. So we have our price and our odometer reading. We also have color. Now these values are categories, not numbers. So there's not a 1 unit difference between say 1 and 2, between 2 and 3. They're just different categories. The Excel Data Pack cannot handle that as a category. So in order for this to work, we need to create new columns for each category. So I will create these different columns, 1, 2, and 3, and then I will say if this value is equal to this value, then 1, else 0. I'm also going to put a $sign before the 1, which locks in that top cell. That means as I move across, it's going to change. So now it's E, this one is D1, this one is E1, and as we go down, it will keep that top row as a reference. Although something didn't quite work. I also need to lock the column C down. So there we go. Great, now it's properly working, and I'll hit this little arrow, it'll go all the way down. Okay. So this is color 1, not color 2, not color 3. This one's color 2, so it's not color 1. It is color 2, it's not color 3. Now these are all formulas. So I'm just going to copy and say paste values. That removes the formula from it. And that way I can change this color 1, color 2, color 3. All right, great. I'm also going to delete this column. I now have the same information, but just spread into 3 columns instead of 1. Now I'll go to Data, Data Analysis, Regression. My input range for Y, so these are my dependent variables, column A. My independent are these 4 columns. I do have labels. So I'll put that all in. We'll hit go. All right, so it has given me the results. These different plots. Super. The first thing I look at here is the goodness of fit. So this is my R squared. It's telling me the proportion of the variance explained by the model. So our version with just odometer explained 64% of the variance in Y. This one explained 70%. So it is better, but not a whole lot better. Look over here at my F value. It says that the probability that all of the coefficients is 0 is very small. So that means that this model could be useful. Finally, I can look over here at my T statistics. This is, are each of these individual values useful? We see that color 1 is not statistically significant at any reasonable value for P. And color 3 has 0 here because it's not actually included in the model because of perfect multicollinearity. That means if I have 3 things and it can only be in one of these 3 categories, then by knowing 2, the information from 2 of them, I automatically know the information for the 3rd. So if it's no for 1 and no for 2, then it has to be yes for 3. If it's no for 1, yes for 2, then it must be no for 3. So it has dropped this out. These 2 variables are now categorical, so it's either yes, it's a value of 1 if it's color 1, otherwise it's 0. It's a value 1 for color 2, otherwise it's 0. And that means if this is 0 and this is 0, then it must be 3, right? So that's okay. This is the way it's supposed to work. Now I have my coefficients for intercept, odometer, and the colors. So what this is saying is that being red, or not red, I don't know what color this is, being color 1 is associated with a increase in the value of the car. Being color 2 is associated with $300 increase, because these are in thousands of dollars, compared to color 3. So these three are all compared. This is 1 compared to 3 and 2 compared to 3. Okay, so that is how we do multiple linear regression. Each of these coefficients is useful. When I say interpret this value, I'll say a 1 unit increase in odometer is associated with a negative 0.05 change in price, holding the other things constant. So assuming that the color is not changing. That is what I used for just this specific value. Now, if I wanted to make a prediction, I would say I have an intercept plus my odometer times, let's say, 30,000 miles, plus, let's say it's color 1. This times 1, that would be this times 0. So my vehicle with 30,000 miles that's color 1 has an estimated price of $15,154.69. And that is our multiple linear regression.